Welcome back to Introduction to Software Reverse Engineering. In this module, we will explore switch case statements. Welcome to Module 15. This module covers switch case statements and some of the ways the compilers can optimize and break them down into if-else statements. The source code and the binaries for reverse engineering used in this module and this course generally are available on GitHub, shown on the screen and available in the video description. The switch statement is a fundamental control structure in C programming that facilitates conditional execution based on the value of a variable or an expression. This construct is particularly useful when multiple conditions need to be evaluated, offering a more streamlined alternative to if-else ladder. The operational logic of the switch statement is straightforward. The expression is evaluated and compared to specific case value. Upon finding a match, the corresponding code block is executed until a break statement is encountered. If no match is found, the code under the default branch is executed, provided it exists. The switch statement offers several benefits, including enhanced efficiency and adaptability compared to a series of if-else statements. This, in turn, can improve code maintainability and reduce the likelihood of errors. However, there are potential pitfalls to be aware of. Omitting a break statement can lead to a fall-through behavior where multiple cases are executed unintentionally. Furthermore, duplicate case values are not permissible and will result in compiler error. Let's dive into the practical part of this module right away and keep this module short. Fire up Ghidra and import switch.exe example program. Make sure to auto-analyze it when prompted. While the program is being analyzed, let's look at the source code of the first function with a short switch case statement that has a few conditions. Now, let's look at the decompiled code of the same function. It is straightforward and matches all the control paths, even though the default option is located in the third place instead of the last place as in the source code. Now, let's take a look at another switch case statement. This one, a relatively large one. It is shown on the screen. The decompiled function is on the screen. It has a few interesting aspects to it. Let's go through them one by one. First, note that the switch statement is wrapped into an if statement which wasn't present in the original source code. This if statement checks if param1 is less than 1. Inside it, there is another if statement that checks if the value of parameter param1 is equals to 0. If so, the code returns a string value for D3DOK error code. Let's check the source code again. Indeed, the source code does not distinguish the first value, 0, or D3DOK in a separate if statement. However, given 0 is unlike other values in the switch case statement, the compiler decided to break down the logic into sort of binary tree in this way. Now, let's go back to the decompiled listing. Observe that in the decompiled code switch statements check if the values are negative in the decompiled window, but are positive in the listing window. This is common for hresult data type that is a complex value packed into a single integer. The decompiled window is applying the signed data type to the values, while the listing window shows raw value. Recall one of the previous modules talking about 2's complement representation of signed integers with a signed bit. Using the raw value is usually more helpful when attempting to find the hexadecimal matching value of an hresult error code. When dealing with large and complex switch case statements, compilers can employ the following optimization techniques. One technique is the use of goto statements to jump between different parts of the switch case or even outside of it. Another approach is to break down large switch case statements into multiple if-else statements. This can make the code more efficient on some CPU architectures, especially when dealing with a wide range of values to check. In some cases, smaller internal switch case statements can be used in conjunction with if-else statements to further optimize the code. In this module, we quickly went through the case switch statements. In the next module, we will shift gears once more and learn more about C strings and review examples of common functions that operate on strings input. As always, the source code and the binaries for reverse engineering are available on GitHub. If you are looking to dive deeper into software reverse engineering, I'd like to recommend my book, Software Reverse Engineering: Navigating x86 Windows Applications with Ghidra. This course draws heavily from the book's content. However, the book itself contains many more examples and insights that can help developing your reverse engineering skills. The book is available in both print and digital Kindle versions on Amazon, making it easy to access and read wherever you are. Additionally, the book covers subjects not discussed in this course, such as reverse engineering of C++ programs, classes, virtual functions, and more. I encourage you to check it out. Thank you so much for watching and learning with me today. If you found this video helpful, please hit that like button and subscribe for more content like this. Your support means a lot to me. If you have any questions or topic you'd like to discuss, leave a comment below or shoot me an email. I'm happy to chat. If you'd like to support me and the channel financially, you can do so through Ko-fi or Patreon. Links are in the description below. Thanks again for watching, and I will see you in the next video.